So coming back over here. So here's number 20. Okay, so the division by primes method is you start with the smallest prime number possible that you know goes into at least one of the numbers. So, for example, looking at 1581 and 3465, I know 2 doesn't go in there, but 3 does. And I just start dividing the numbers by as many 3s as possible. And as soon as I run out of 3s, so looking at 385, I can't take another 3 out, then I would jump to the next number, which is 5. And so with division of primes method, you're not going to have to know too many prime numbers in the list. Like you should have, I would say, up to about 41 memorized. I mean, they're not that hard to track down, but you should be able to answer this type of question before you get well before 40. Does that answer your question?
Yeah.
Okay. Anything else while I'm here?
No, not for now.
Okay. Alright, we go back to the main screen. Okay, question. And I kind of want to know how this person got their title to be San Jacinto College. That's kind of cool. San Jacinto College North Student Government? How do you think? Okay, anyway, so if you want to turn your mic on, you can talk.
Okay.
You say you probably want to turn off your webcam, though.
Oh, right.
I mean, not that it matters, but, you know, whatever. All right, so converting to a specific base. Let me pull up that question. Unfortunately, when I share my screen, I can't see what anyone's typing, but that's why I have you turn your mic on so you can just talk to me in case you want to see that.
Okay.
Okay, so you said anything off the first page?
Yes. So
Okay.
kind of like, I guess, number 3.
Number 3? Okay.
Yeah.
All right, well, let me actually jump up to 1 here.
Okay.
'Cause that's kind of the format that I think will help get it straight in your head as far as how one sets that up. And then I'll jump down to number 3 and we can kind of go through that. But you see this green stuff here where I've got 8 to the 0, 8 to the first, 8 squared, 8 cubed?
Yes.
So whatever base I give you to expand it in, you want to start with that format. So you want to kind of estimate, not really estimate, I'll kind of pull a calculator up and we can kind of see for a second. Let me do that. Let me get a calculator up. Because you can use a TI-84 on this test. Because I'm mainly checking to see that you actually know how to set these techniques up. Okay, so what I would do is I'd say, well, 3,456. I know 64 is smaller. You know, I might not know 8 cubed. Let's see if 8 cubed goes in there. So 8 cubed goes in there 6 times with a little bit of leftover. Would 8 to the 4th go in there? So 3, 4, 5, 6 divided by 8 to the 4th. And you can see that 8 to the 4th is already bigger than that. So you know you don't have to expand it out all the way to the 4th power. You can stick with the 3rd power one. Okay, so let me jump down to number 3 then, which is what you really asked me about. Okay, so number 3, I would do the same thing. I would start and figure out what the largest power of 7 that goes in there. So I know 7 squared is 49, so that's too small. 7 cubed is 343. All right, that's bigger. But when I go to 7 to the 4th, 7 to the 4th is already bigger than my target. the 1,256. So I know that I can start with 7 cubed. So then what I would do is I'd fill in these blanks here. 7 cubed, 7 squared, 7 to the first, 7 to the 0th power. And then I would go back and figure out how much does each one go in. So if I take 1256 divided by 7 cubed, it goes in there 3 times evenly with a remainder left over. So then I want 1256 minus 7 cubed, and that leaves me with 913. And so then I want to see how many times does 7 squared go in there, so divide that by 7 squared. Let's see, 18. That's not. Oh, I see what I missed. Whoops, I missed something. Okay, hold on. Let me try this again. 1256 minus 3 times 7 cubed. So I missed that 3 times part. All right, so that leaves me to 227 as my remainder. I'm sorry. And then I want to take that and divide that by 7 squared. And that goes in there 4 times with some sort of remainder. So then 227 minus 4 times, now 7 squared is 49, so I just jump to that. And I get a remainder of 31. And so now I'm at 7 to the first. So take that divided by 7. Goes in there 4 times with a remainder. So 31 minus 4 times 7. And I get 3, and that's that last position. That's where I get the 3 from. So whatever number you're given, you just want to do that with the base. Figure out the biggest base that'll go into it without going over it, and then focus more on the remainder each time.
Mm-hmm.
Okay?
Okay.
Anything else while we're here?
Would it be the same for like all the bases? Like if it would be like base 10 or base 5?
Yeah. Okay. So let's say I wanted to go base 5, since you brought it up.
Mm-hmm.
Then I would divide by, let's see, I'm thinking 5 cubed should be big enough. Okay, 5 cubed works, but maybe 5 to the 4th. And so if I try 5 to the 4th, oh, I got 5 to the 4th to go in there. So I'll have 5 to the 4th, 5 cubed, 5 to the squared, 5 to the first, and 5 to the 0. And I think 5 to the 5th power is already too big. Yeah, I'm already at 3,125. So if I was going to do it to the base 5, I would have 2 5 to the 4th. Then I figure out the remainder, divide by 5 cubed to figure out, that same process, but they all start off the same.
Okay.
Okay?
That's it. Thank you.
Okay. All right. What else we got? I don't see any other questions typed in there, so if anyone wants to turn their mic on, or if you want to type a question in, or a little more exciting when we're actually chatting. Number 4, okay. Sorry, I had a big old cough there. All right, let me go to number 4. Oh, the set one. Okay. So Jacob, if you want to turn your mic on, you can. Or not. Okay, so here's number 4, and I actually messed up on when I typed it. I mean, it's a review sheet, so I don't feel too terrible about that. But the idea is that the union between the two sets has to be bigger than at least one of the sets. So, it's got to be bigger than, since set B has got 15 elements in it, then the union of the two sets has to have more than 15. Otherwise, there wouldn't be any overlap at all. And so the formula that I'm expecting you guys to know is this one right here, that the number of elements in the union is the same as adding the elements in each set, so set A plus set B, and then subtract off the intersection. And so for us, it's just a formula that we just plug in the numbers. So I said there are 17 elements in A or B. There's 4 in A, 15 in B, minus this intersection, and that's what we're solving for. So here, if I get bring the, let's see, 2 over, then I should get that there's 2 elements in the intersection. Because 19 minus 2 gives me 17. So, anyways, hopefully that helped, Jacob. So you'll see something like this on the test tomorrow. Or test, not necessarily tomorrow, but whenever you take it. You're very welcome. Anyone else got something? Can we use the tree method? Like 14 and 18. All right, Jocelyn, if you want to turn your mic on, you can. Let me jump over to 14 and 18 so I can see exactly what you're talking about. Oh, okay. Yeah, 14. 14 I leave very open-ended. Let me make that one bigger so you guys can see it. So with number 14, I don't really specify how you do the prime factorization. The question is, give me the prime factorization. So if you want to do a tree diagram with that one and do that approach on 14, then you're more than welcome to on that. I think I just said, well, I know 3 goes in there, so I took, can I go back here so I can show you exactly what I did? So I said, well, I know 3 goes in, and so then I'm like, let me try 3 again, and let me try 3 again. So I just kept trying numbers until, so here I'm at 245, but when I try 3 doesn't work. So I know I've run out of 3s for the prime factorization part. Looking at 245, I can clearly see that 5 goes in, and I get 49. Now, if I forget and I don't recognize that 49 is 7 squared, when I try to divide a 5 in again, it's not going to work for me. So then I just go up to the next number and go, hey, what goes into 49? Well, 7 does. So that's the method I went through and did this, but you're more than welcome to do a tree diagram on that one. And then you asked about 18. 18, yeah, same thing. Find the LCM of 4 numbers. So if, let me make it bigger. Okay, so same thing on that one. If you want to use a tree diagram to break up each of the numbers into their prime factors, that's fine. As far as the LCM goes, you just want to collect up the most of each exponents you can. So 4 has 2 squared in it, 14 has 2 times 7, so I know 2 squared's got to be in the LCM. I know a 3 and a 5 and a 7 have to be in the LCM. So, but how you break the numbers up, I kind of leave very open-ended for you to look at. So if you want a tree diagram it, you're more than welcome to. So hopefully that answers your question there. Number 19, so Janet, you asked if there's a specific formula for that one. Okay, let me go over to 19. Yes, actually, there is this very specific formula, and that is the formula. Let me try that again. Try it. See, come on, stop doing the box. I'll try to make this bigger so that you can see what I'm talking about here. Okay, so in number 19, yeah, this formula right here is that if given any two numbers, the product of the two numbers and the product of their GCDs and their LCMs are equivalent. So in this case, I tell you the product of the two numbers is 6,448. I give you an LCM and I want you to find the GCD. So, but that is a very specific formula, and that is the only way you'll be able to answer this type of question, is just by knowing that relationship between the GCD and the LCM. But on the good note, you now know to expect this, so just memorize the formula and you'll do just fine. All right. Oh, you're welcome. San Jacinto College Student Government. I just love that your title is that. We're going to be asked to use a specific technique to abstract or multiply or divide just like 9 and 10. Okay, so let me look over at 9 and 10. Okay, yes. Yes. Okay, let me make these nice and big. Okay, so I threw 8 in there just why not? So you're going, like in number 8, I'm going to give you two numbers, and I'm going to have you use this illustration method of how you would break up base 10 blocks. I figure if you can't answer it now on a test, you're going to have a hard time as an elementary school teacher. But anyways, so you just diagram it somehow, some way, and then I'm going to bring up breaking up and bridging, and I'm going to bring up repeated subtraction. And then notice this, my little disclaimer there. There are other estimation techniques that we've seen, things involving rounding, things involving, let's see, using the range is another method I can think of off the top of my head. So I would go through your notes on some of the estimation techniques and just make sure you're brushed up on the terminology, so that whatever particular concept I ask you about, you're able to demonstrate that you can show me you actually understand that particular method. So not a lot of questions like that, but there are a couple of cases where I'll want to see a couple of different estimation techniques, and it's not going to be open-ended. It's not going to be, hey, why don't you pick something and show it? I mean, I'm going to look for a very specific technique like breaking up and bridging and repeated subtraction. Okay, you're welcome. Anyone got anything else? Has 11 been discussed yet? Well, we can discuss it now, Jocelyn. Oh, okay. No, we haven't talked about that one yet. Let me make it bigger so we can address it. This is another method that involves a very specific technique. The intersection of sets method. So the trick here is to first break them up into prime factors. And the intersection of sets method kind of did it two different ways. One method is we made this sort of Venn diagram that illustrated like 60, for example, is 5 times 2 times 2 times 3. And 252 is 2 times 2 times 3 times 3 times 7. And so you can kind of see there's an overlap between the two numbers. So this set that's the overlap, would be our GCD. So you can kind of come over here. If I see a 2 in each list, I see a 2, I see a 3. So you could also just, from this list of numbers, circle the ones that are in common, and the ones that you circled would be the GCD. And then the LCM would just be the GCD plus the additional numbers in each side. So the intersection of sets methods is just a nice visual way to very quickly identify the GCD and the LCM. But yes, I'm looking for a specific structure on how you organize the facts for that particular problem. Can I go over 6? Yes, I can. Oh, 6, probably 6 and 7. The lattice method, both for addition and multiplication. Okay, so 6 specifically, the way the lattice method works is underneath each digit, each column of digits, I'm going to essentially add up what I see. So 9 plus 8 is 17. So there's sort of we divide that up into two triangles by cutting it with a diagonal line. And so we put a 1 up in the top piece and the 7 in the bottom piece. And then 2 plus 7 would be 9, so a 0 goes up top and a 9 goes down below. 5 plus 4 is 9, so a 0 there and a 9 there. And just add up each column. And then to get our final answer, I'm going to add the diagonal rows together. So 7 drops down, 1 plus 9 is 10, so we get a 0 there, carry the 1, 0 plus 9 is 10, again carry the 1. Anyway, so that's what we're doing there. In the multiplication method, so I take my two numbers and I put one number horizontally on the outside, and I take the other number and have it go down vertically, and then sort of the same idea where I break up the box using diagonal lines. And then I just multiply the corners, kind of like a Punnett square from biology. So 3 times 2 is 6, so you get a 0 and a 6 there. 2 times 4 is 8, so 0 and 8 there. 3 times 3 is 9, so you get a 0 and 9. And then 3 times 4 is the 12, so you get a 1 and 2. And then I'm going to add the diagonal numbers together. So the 2 gets dropped down, the 9 plus 1 plus 8 is 18. So we get an 8 there, carry the 1 for the next diagonal, and that's the 1 plus 6 is 7. So then our final answer would be 782 for that. And again, so you will see those two specific problems on the test with obviously different numbers, but again, I'm looking for that visual organization method on how to multiply and add. Okay. Oh, you're welcome. Okay, make sure I don't miss a question. Jocelyn asked 15, and then I'll look at what you typed there, Liz. So let me jump over to 15. Okay. Oh, that's a good one. Find the prime factorization. Okay, so the trick on 15 is you don't have all the sets of numbers are not prime themselves. So this is where you got to go in and use exponent rules to break up each of the numbers into their prime factors and then collect up all of the prime numbers. So for example, 4 cubed I can rewrite as 2 squared, and then our exponent rule is multiply the exponents together, so that'd be 2 to the 6th, because 2 times 3 is 6. The 50 is, in its prime factorization, it's 2 times 25, so that's 2 times 5 squared, and we're raising that to the 2nd power. So again, using our exponent rules, we can distribute the exponent into each number, so that gives us a 2 squared and a 5 to the 4th. And then the 9 is just 3 squared to the 4th. That gives us 3 to the 8th. And then again, I want to use exponent rules to combine all my common bases together. So 2 to the 6th and 2 squared. 6 plus 2 gives us 8. 3 to the 8 is already done. 5 to the 4 is already done. But so you're going to see some numbers like, so you're going to see a problem like this where you have to break up each individual number into its prime factors and then use exponent rules. All right. Let me read Liz's question. Liz said, can you do an example for front end with adjustment similar to the notes for 3-4? How do you know how much to round up? Okay, so you want me to make up a problem? Oh, that's terrible. Okay, so let me think. Front end adjustments. Actually, we should probably pull one off the review because it's just an estimation technique. So let me go back to the lattice ones. Yeah, that'd be a good one to pull from. Okay, so front-end adjustments, and again, the estimation technique is you kind of have to pay attention to, I guess, what the goal of the problem is. So if I'm trying to get to the nearest thousandth, then I want to average or estimate each number up to the closest thousand. So 8,500 would round up to 9,000, and then 1478 would actually round down to 1,000, and so my estimation would be that the answer should be somewhere close to 10,000. And so that's kind of how front-end adjustment works, in that you're just looking at the first number and then deciding whether to round up to the nearest, round up to 9 or down to 8. Anyways, hopefully that helped. All right, what else you guys got? You can type your question. You guys actually have been very quiet, so I don't mind trusting you and let you turn your mics on if you want to try that approach. Or you can type a question in. Grouping two nice numbers question. I'm trying to think if was that on my review, or you just want me to come up with a good example. Grouping to nice numbers typically, yeah, an example. Okay, so grouping to nice numbers typically means we're adding several numbers together. All right, let me kind of go get a piece of paper here. So let's say I'm adding up, I don't know, 256 plus 357 plus 128. Okay, so what I would do is I would group up each, I guess, the hundreds position, the tens position, and the ones position. So that would be 200 plus 300 plus 100, which is 600. Okay, and then I would go 50 plus 20, which is 120. And then I would go 6 plus 7 plus 8, or 8, which is, what, 1421. And so now I've got a little bit smaller numbers, or a little bit easier numbers to work with. So now I just want to do 600 plus 120, which is 720. And then I want to add the 21 on top of that, which is 741. So the grouping with nice numbers technique simply means I'm going to see what nice numbers you picked, and then you eventually end up with the actual sum itself. So it's not really an estimation technique, but more just an organization technique about how else could we group these numbers together so they're a little bit easier to add. Okay. One thing, since I've got so many of you here, one thing I'm gonna just throw at you guys real quick and just make sure we're all on the same page with is the divisibility rules question. This is a very easy question to get full credit on, and at the same time, if you have no idea what you're doing, it's an easy one to lose a letter grade on. So I've seen students that have no idea how to even do divisibility rules and then just kind of miss the point. And then it just, yeah, it's literally letter grade if you miss this. And this is all I'm looking for with divisibility rules, is just tell me where to look in the number to decide if a number goes into it or not. So a couple easy examples. If I want to see if 2 goes into it, all I have to do is look at the first number, the 3. As a matter of fact, that 3 can tell me whether 5 goes into it, and it can also tell me whether 10 goes into it. And then that symbol there just means it's not divisible by. The 4, you have to look at the first 2 digits. The 8, you have to look at the first 3 to decide if they go in or not. Anyways, so I'm just throwing a caution out there. Make sure you look over divisibility rules. And on top of that, the other area that I saw students just hand me a letter grade on were properties. So please, 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 make this a little bit bigger here. Please make sure that you know the names. I'm not going to, so my test question is not illustrate the following. I'm going to give you a statement and you have to tell me what it is. So if I give you A plus B equals B plus A, then I would expect you to tell me that it's commutative of addition. Or if I have some number plus 0 equals that same number, then I would expect you to tell me that it's the identity property of addition. So please make sure you've reviewed all the vocab associated with properties and just look at some different scenarios that I could throw at you. Because again, between properties and divisibility rules, I had students they went from making an A to a C in just 1 page on the test just because they weren't so clear on how those things looked. Let's see. Okay, no. Liz asked, do we need to know divisibility rule for 7? And the answer is no. I never even taught it and never even showed up in homework. 11 I was okay with. 11 is sort of a trickier one, but 7's got an even nastier pattern associated with it. So most time you won't see 7 when you talk about divisibility rules. 11 is kind of pushing my luck even, but like I said, it's got a nice pattern to it, so I don't mind throwing it on the test. Anything else? Oddly, this does feel like my face-to-face class sometimes. You ask questions and the whole room just sits there quietly. I guess I can ask this and see if this is something that would be an interest to just the group that I have. I've entertained doing face-to-face reviews in the past. I understand I've got students from all over the Sanjak system. So unfortunately, if I do a face-to-face review, it would be at North Campus, and I would probably do something like 5 or 5:30. But just with the group that I have here, is that something you guys would be interested in? Or do you think the videos and the online review is sufficient to get you ready for the test? It wouldn't be for test 2, in case you're wondering. It'd be test 3 or, I guess test 3 and the final would be the two that I'm thinking about. Okay, so Jocelyn, if I open that up, then you'd be willing to show up. Is 5:30 a good time? Okay. And Liz, you say you work after. Well, I mean, I understand it's not going to be perfect. I'm not going to catch everybody, but if there's interest in doing it, then I'm okay with. I mean, I'd still do this virtual review. I still think it helps to give students a chance to jump on and ask questions, or hear me talk a lot, because that's basically what you guys have done tonight. Make it face-to-face. We normally get off at 6, but okay. All right, then what I'll do for test 3 and the final, and you're probably thinking, what about test 4? Well, test 4 is actually a take-home test. Yay! You don't have to come to campus for that one, mainly because we make you come up for the final. Probably Thursday? You think Thursday would be a good day, or like Wednesday or Tuesday? I think the night before would be fine. Thursday's good? Okay. All right. Then we will hypothetically, if you guys want to pencil in, and pencil please, don't put it in pen. Then for test 3 and for the final exam, I'll have a Thursday evening review somewhere on North Campus around 5 or 5:30. So. But again, I'll have this as well. So I'll have a probably Thursday night, like 9 o'clock. Anyways, anything else? Almost 10 o'clock, so I don't turn into a pumpkin or anything. But if you guys have any other questions you want to look at, I'm more than willing to do that. Or if there's anything else you want to chat about that'll help you be more successful in class. Probably should be careful not to open that too much up. Closure property multiplication. Was that? Let me be careful on that one. That was that on test 1? I'm just looking at my test real quick. My secret folder that's got all my exam stuff on it. Yes, you will see closure. Where is it? Where are ya? Yes, you will see closure property of addition on this test. And not of multiplication. Yeah, you'll see closure property. And the idea being, I give you a set, you pick any 2 elements of the set, and for multiplication, you just multiply them together and see if you get a number that's in the set. So, like 1, 2, 3, 1 times 2 is, well, 2's in the set, and 1 times 3, 3's in the set, but 2 times 3 is 6, and 6 is not in that particular set. So that would fail the closure property multiplication just on that one counter example. So there's sort of the hint you want to watch for. You want to look for a counter example in the event that it's not closed, and then if there's a counter example, then just tell me what that counter example is, and then that means that therefore it's not closed under addition or closed under multiplication. So, but yeah, you will see closure property. Anything else? Nope. Okay. Well, Jocelyn, you're welcome, and if you got, I mean, if you got nothing else, I'll just kind of shut this down, and now I'm recording this. Again, I don't think you six probably are going to want to watch the video, but I'll post the video on the announcement part on Blackboard. Really, Diana? Really? You're here right now. You can ask whatever you want. I'm teasing. Okay, yeah, I will, as soon as I get off with you guys, I'll post it. So, all right. In which case, I'll go ahead and stop this now, and I will go post it so Diana can go back and watch it. And San Jacinto College Student Government, it's been a pleasure chatting with you.